All right, everyone should have a worksheet that looks like this in front of them. You have it says balancing chemical equations, and you have a people of a seesaw on it. And there are rules to balancing chemical equations. Okay, let's start with this one. Remember this. A balanced chemical equation must have equal numbers of each type of atom on both sides of the arrow. An equation is balanced by changing coefficients in a somewhat trial and error fashion. It is important to note that only the coefficients can be changed, never a subscript. So what is the difference between a coefficient and a subscript? All right, so you have the term 2x squared. 2x squared. The 2 is the coefficient. The 2 is the coefficient. The little 2 is a subscript. The little 2 is a subscript. A submarine goes on the bottom. A subscript goes on the bottom. A coefficient goes in front. It never goes behind. It always goes in front. The coefficient times the subscript gives the total number of atoms. So, for example, you would multiply 2 times 2 here. 3 quick examples before balancing equations. Okay, so if I have a coefficient of a 2 and a subscript of a 2, there are 2 times 2 atoms of hydrogen. Total 4. Here's another example. I have a coefficient of 2, a subscript 2, and then a pretend 1 here. I don't need to write a 1, but there's, it's assumed there's 1. So there's 2 times 2 atoms of hydrogen, total 4, and 2 times 1 atoms of oxygen, so a total of 2. Here's a really complicated example. I have a 2 coefficient here. I have 2 nitrogens outside the parentheses. This is an ammonium, so I have 2 nitrogens times 2. I have 4 hydrogens times 2, and then times 2 again. And then I have an S times 2. There are 2 times 1 times 2 atoms of nitrogen, a total of 4. Again, 2 times 1 times 2. There are 2 times 4 times 2 atoms of hydrogen, 2 times 4 times 2. So that's a total of 16. And there are 2 times 1 of sulfur, 2 times 1 of sulfur. So that's how subscripts and coefficients work. Let's put this to an actual example. On the next page, I'm going to walk you through example number 1. Example number 1. Okay, let's do example number 1. Okay, please make sure you have a pencil only, not a pen. So when we start off with the first one, number 1, H2 plus O2 gives you water. All right. Everything on the left side of the arrow has to be balanced with the right side of the arrow. So the amount of hydrogens on this side have to equal the amount of hydrogens on this side. The amount of oxygens on this side have to equal the amount of oxygens on this side. And the only space that I can write numbers are the coefficients which go in front. Okay? There's 2 ways you can do this. The first is the very, very slow way. So we'll do it the very, very slow way first. Okay? All right. So I have my sides of the arrow. How many oxygens do I have right now? Hydrogens. I have 2. 2. How many oxygens do I have over here? I have 2. Go to this side of the arrow now. How many hydrogens do I have? I have 2. How many oxygens do I have right now? I have 1. This equals this, but oxygens are not equal. So what I'm going to have to do is I'm going to have to make the right side equal to the left side. So what can I do? Well, I'm going to put over a 2 right here. The reason I put 2 right there is so that the number of oxygens will be 2, because 2 times this 1 oxygen is now 2 oxygens. Okay? So wait a minute, you're saying, no, they're balanced now. Well, no, they're not. No, they're not, because now I have a 2 that multiplies this hydrogen times 2. So now, over here, I have, because I have a pencil now, you see, you guys don't have a pencil. I told you to get one. You have a 4. Well, now this one over here isn't balanced anymore. So now I need to come over here and put 2, and erase this, and put 4. So, now they are balanced. 2 in front of this, nothing in front of this because it's assumed to be 1, 2 in front of this. That's balanced. Okay, let's look at the next example. The next example I want to look at is number 5. Number 5. Question number 5. Number 5. Okay, you have sodium plus H2O yields NaOH plus H2. Well, all right, you want to do this the slow way? Let's do this the slow way. Na equals hydrogen equals oxygen equals. On this side of the arrow, Na equals hydrogen equals oxygen equals. How many sodiums? 1. How many sodiums? 1. How many hydrogens? 2. How many hydrogens? How many hydrogens? How many? This one plus 2 more. 3. How many oxygens over here? 1. How many oxygens over here? 1. Not balanced. Okay, as a word of advice, odd numbers are very difficult to work with. Odd numbers are very difficult to work with. As soon as you can, change them into even numbers. So how am I going to do that? Well, if I put a 2 in front of this thing, in front of NaOH, that will change the number of hydrogens I will have on this side to 2. But what else will it do? It will also change the number of sodiums I have to 2. And it will also have the total, it will change the total number of hydrogens. My bad. Screwed that up. See, I didn't count the plus sign. It will change it to 4. It will change the number of oxygens I have to 2. Okay? Well, clearly, not everything's balanced. So I have 2 sodiums, 1 sodium. I need to put a 2 in front of this so that now I will have 2 sodiums. I have 2 hydrogens over here, 4 over here. What do I need to put in front of this? That's right, 2. So now 2 times 2 is 4. Okay, and then oxygens. I have a 2 in front of here. 2 times 1 is 2. So 2, 4, and 2. It all checks out. It's balanced. Okay? Now, let me show you the fast way. Let me show you the fast way. Once you've practiced with this, doing it the slow way a number of times, you will be able to do it simply by looking at the left and the right. Okay, here we go. How many sodiums? 1. 1. 2 hydrogens, 3 hydrogens. Odd numbers are bad to play with. Put a 2 here. Okay? 2 sodiums, 2 sodiums. 2 hydrogens, 4 hydrogens. I needed 2. 2 oxygens, 2 oxygens balanced. Eventually, I want you to get to that point and do it that fast. Okay, the next problem. Everybody jump down to number 9. Okay, this is a toughie. C7H6O2 plus O2 gives you CO2 plus H2O. All right, carbons, hydrogens, oxygens. Carbons, hydrogens, oxygens. 7 carbons, 6 hydrogens, 2 plus 2 oxygens, 4 oxygens. 1 carbon, 2 hydrogens, 3 oxygens. I can tell you right now, odd numbers are bad to play with. They're confusing. They're going to confuse you. So let's try to get rid of them. Let's try to get rid of this 7 first. Let's put a 2 in front of this. So a 2 again multiplies absolutely everything in there. Absolutely everything. So now 7 becomes 14. Now 6 becomes 12. Now oxygens, the total number on this side, 4 plus 2 becomes 6. Over here, we now need 14 carbons, don't we? We need 14 carbons. And now the number of hydrogens is 2. Well, we've got to fix that, don't we? We need 12. So we've got to put a 6 in front of this thing, so that's 12. And now look what happened to the oxygens. The oxygens became, let's see, 2 times 14 is 28, plus 6 more is 34. Well, how are we going to get 34 oxygens over on this side? How in the world can we do that? Well, let's see, what goes here? That's 2, what number can I put right there? 15, that's 30. 30 plus 4 is 34 oxygens. Okay? So, your job is to do all the problems that you can today. You should be able to do almost the entire thing. Work at this, replay this video 500 times until you understand how to balance equations. It's extremely important.